Now let's solve exercise 1.3 of NCERT class 12 mathematics. Question number 1. Here f is from set of 1 2 3 to set of 1 to 5, and g is given as a function from set 1 to 5 to 1 3, and given by f is this and g is this. Write down GOF. So this is the question. So f is from the set of 1 2 1 3 4 to a set of 1 to 5. G is a function from the set 1 to 5 to set of 1 comma 3. Codomain of f is exactly the same as domain of G. That's why GOF is defined from the set 1 3 4 to set of 1 3. And f is given by set of ordered pairs 1 comma 2, 3 comma 5, 4 comma 1, and G is given by the set of ordered pairs 1 comma 3, 2 comma 3, 5 comma 1. So GOF, first element of domain of GOF is 1, so we need to find out GOF 1. And GOF 1 means G of F1. And F1 means the second element of the pair whose first element is 1. So we have to observe this. F1 is given by 2. So we have to replace F1 by 2 over here. So G2. And G2 means second element of the pair whose first element is 2. So we have to observe in G, the first element is 2 and its second element is 3. So G2 is equal to 3. So that is 3. Now GOF, second element of domain of GOF is 3. So GOF 3. That means G of F3. And F3 means the function's value at x is equal to 3. That is the second element of the ordered pair whose first element is 3 in F, which is 3 comma 5. And here x is 3 and fx is 5. So F3 is 5. So that is equal to G5. So we have replaced F3 by 5. Over here we get G5. Now G5 means the value of G, x, where x is 5. That means second element of the ordered pair whose first element is 5, which is 5 comma 1. So here G5 is 1. So that is 1. Now the next element of domain of GOF is 4. So GOF 4, which means G of F4. And F4, that means the second element of the ordered pair whose first element is 4. That is this ordered pair. Here second element is 1. So this is F4. So we have to replace F4 by 1. So we get G1. G1 means the value of Gx, where x is 1. That is the second element of the ordered pair whose first element is 1. So we observe in the set G. So this is 1 comma 3. That is G1 is equal to 3. So G1 is equal to 3. So we write here 3. So GOF is defined as the ordered pairs. For 1, GOF is 3. So 1 comma 3. For 3, value of GOF is 1. So 3 comma 1. And for x is equal to 4, GOF is equal to 3. So 4 comma 3. Now question number 2. Here f, g and h are the functions from R to R. So we need to show that f plus g OH is equal to FOH plus GOH, and F into GOH is equal to FOH into GOH. Now, by the concept, F plus G OH X is equal to F plus G of HX, and that is F HX plus GHX. FHX, FOHX, and GHX is written as GOHX, which may be written as FOH plus GOHX. If we eliminate X from both sides, we get on the left hand side F plus GOH is equal to, on the right hand side we get FOH plus GOH. Similarly, you can prove the second part. Now, question number 3, find FOF and FOG. If first part, fx is equal to mod x and gx is equal to modulus 5x minus 2. Let's find GO first. So GO of x is equal to g of fx. And g of fx means we need to replace x by fx in gx. So on the right hand side we have 5x minus 2. Here we have to replace x by fx. We get modulus 5fx minus 2, modulus closed, is equal to. Now we have to replace fx by mod x because it is given fx is equal to mod x. So modulus 5 mod x minus 2 modulus close. This is required expression for G of x. Now let's find fog x is equal to f of gx. F gx means we have to replace x by gx in fx, so we get on the right hand side modulus gx. Then we have to substitute the value of gx, which is modulus 5x minus 2. So modulus 5x minus 2 modulus close. So this is required expression for fog x. Now the second part of question number 3, I have given an example of G of x, so I'm going to skip it. Now question number 4, that is fx is equal to 4x plus 3 upon 6x minus 4, where x is not equal to 2 upon 3. We need to show that of x is equal to x for all x is not equal to 2 upon 3. And what is the inverse of f? So first, to prove f of x is equal to x. So f of x is equal to f of fx, which means we have to replace x by fx in fx. So here in fx we have to replace x by fx. So on the right hand side we have to replace x by fx for finding fx. So we get 4fx plus 3 upon 6fx minus 4. So we get 4fx plus 3 divided by 6fx minus 4. Now here we have to replace fx by the expression 4x plus 3 upon 6x minus 4 because this is the value of fx. So we get 4 into 4x plus 3 upon 6x minus 4 plus 3 divided by 6, 4x plus 3 upon 6x minus 4 minus 4. In the numerator, taking LCM, we get 6x minus 4 in denominator, and in the numerator here left 4 into 4x plus 3, so we get 4 4s are 16x plus 4 3s are 12 plus, and 6x minus 4 will multiply 3, so 6 3s are 18x, and minus 4 into 3 minus 12. Similarly, in denominator we have to take LCM, and we have the same expression as LCM, 6x minus 4 in denominator. So we have 6 into 4x plus 3, so 6 4s are 24x plus 6 3s are 18 minus 4 into 6x plus 4, so 4 6 are 24x, and minus into minus plus 16. Here this 6x minus 4 is cancelled by 6x minus 4 from the denominator. So we have in the numerator plus 12 will cancel minus 12, and in denominator 24x is cancelled by minus 24x. So finally we have 16x plus 18x, which is 34x, upon, in denominator we have 18 plus 16 simply, which is also equal to 34. Now the 34 is cancelled by 34, and we get only x. So we have proved that f of x is equal to x. Now we have to find out inverse of fx. Let y is equal to fx, or y is equal to 4x plus 3 upon 6x minus 4. Transposing 6x minus 4 to left hand side, we get y into 6x minus 4 is equal to 4x plus 3. Or if you open up this bracket, 5 will multiply both of them, so we get 6xy minus 4y is equal to 4x plus 3. Now in the next step, we have to transpose 4y to right hand side and 4x to left hand side. We get 6xy minus 4x is equal to 4y plus 3. Now we may take x common out of these two terms. So x in the bracket, we are left with 6y minus 4 is equal to 4y plus 3. Now transposing 6y minus 4 to right hand side, we have x is equal to 4y plus 3 upon 6y minus 4. In this step, we have to replace x by f inverse x and y by x, replacing x by f inverse x and y by x, we get f inverse x is equal to 4x plus 3 upon 6x minus 4. Now question number 5 is state with reason whether the following functions have inverse or not. So as we have learned that a function is invertible only when if it is bijective. F is given by the set of ordered pairs 1 comma 10, 2 comma 10, 3 comma 10 and 4 comma 10. That means each and every element of the domain has the same image 10. So obviously this is many one function, since every element of domain has same image. Therefore, the function is many one, so the function is not bijective. And that's why it is not invertible. F is not invertible. Or in other words, we can say f does not have inverse. Now let us consider the second part. G is a function defined from the set of 5, 6, 7, 8 to set of 1, 2, 3, 4. And G is set of ordered pairs 5, 4, 6, 3, 7, 4, and 8, 2. Again, 5 and 7 have the same image in codomain. That means two elements of domain have the same image 4, while for 1 1 function, each and every element of domain should have a distinct image in codomain. So G is not 1 1 function since 5, 4 and 7, 4 belong to G. It implies that image of 7 is equal to image of 5 is equal to 4. So since this is not 1 1 function, this is not a bijection. Thus, G is not a bijection. And so G doesn't have inverse. Now let us talk about part third. Here H is a function defined from the set of 2, 3, 4, 5 to 7, 9, 11, 13. And H is given by the set of ordered pairs 2, 7, 3, 9, 4, 11, and 5, 13. So we observe that each and every element of domain of H has a distinct image in codomain. That is, the image of 2 is 7, image of 3 is 9, image of 4 is 11, and image of 5 is 13. Each and every element of domain has a distinct image in codomain. That's why H is 1 1. And there is no element in codomain which doesn't have pre-image in domain. So H is 1 1 on 2. That is bijective. And thus H has inverse. So H is the only function which has inverse out of these three.